Hey guys, welcome to Linear Inequality Word Problems. Go ahead and read this top paragraph on your own, but a quick summary just to let you guys know what we're doing today in class is actually applied real world all the time. I mean, definitely different scenarios, but these kinds of situations and the graphical displays do occur quite often. So maybe not necessarily exactly the way we're going to do it in class, labeling the variables and such, but it does happen very often out in the real world, which I think is pretty cool. So anyway, let's go ahead and get started with number one. Suppose your class is raising money for the Red Cross. We make $3 on each basket of fruit and $5 on each box of cheese that you sell. How many items of each type must you sell to raise more than $100? So what we're going to go ahead and do is label our variables. And so we're going to label with what x equals, what y equals, and when we do this, what are the two different objects that they are talking about in this story problem. So hopefully you realize, and if we reread, they have a basket of fruit and a box of cheese. So let's go ahead and talk about how x is the number of fruit baskets, and y is the number of cheese boxes. And so it's asking us how many of each type of items. Now hopefully you realize, well, there's not one solution. There's going to be many solutions to sell these items and raise more than $100. So let's go ahead and create our two inequalities for that. So this is going to go back to all that work that we did with the story problems of inequalities before. So we'll start with that money equation. So for our money equation, you're making $3 on each fruit basket, so that's going to be 3x. Then $5 on each cheese box, so that's going to be our 5y. We want to sell more than $100 worth, so we're going to go ahead and do that. Now, we don't have a second equation for this because it is just going to be this one scenario, but it is an inequality story problem, so that's why it fits in here. So let's go ahead and this is our starting equation that we'll box in, then we'll solve for y. We'll put this into slope-intercept form and graph it. So we'll start by subtracting 3x from both sides. We get 5y is greater than negative 3x plus 100. Divide both sides by 5, and we have y is greater than negative 3/5 x plus 20. Okay, so we'll go ahead and graph this. Now, as we graph this, what we're going to make sure we do is label our x and y axis, okay? So for our x-axis, remember at the top we talked about how x equals the number of fruit baskets. We just recopy that, so not too challenging. We've already said x equals fruit baskets. And so y we labeled as cheese boxes. So let's go ahead and label our y-axis as a number of cheese boxes. And so from here, we're going to go ahead and graph this. So our starting point is 20. So find 20 on your y-axis. Then our slope says down 3, right 5. So go ahead and do that. All the way down. All right, now, so since we have that, we'll go ahead and do our dotted lines. So if you don't have a straight edge, please grab one and pause the video. I want this to be accurate and nice and neat as a good reference for you. I guess on my y-axis I don't need an arrow, it just starts at 20. Okay, and then the last thing that we have to do is figure out how we're going to find our solution. So it's y is greater than. So greater than tells me I shade above the line or to the increasing y values. Increasing y values is going to be greater than 20. So for this fundraiser to sell more than $100, you have to sell above this line. So a lot of times when I see these kinds of problems on tests, they're going to ask like something along the lines, you know, write down some scenarios of what would work. And you would say something like, well, if you sell 26 fruit baskets, you know, then selling 6 cheese boxes is enough. Okay, so any of the points in here. So again, if you sell 13 cheese boxes and maybe 21 fruit baskets, again, that's greater than $100. So that is how this is worked for testing situations. Okay, so let's go ahead and open this up. We have this one right here. And so we'll do problem number 2. You could see it's pretty involved. We'll do that next time I see you in class. So let's jump to number 3. So this is on the 3rd page. So for number 3, what I want us to focus on is just making sure we write accurate systems of inequalities. So we're not solving, we're just writing the equations. Let's start with the first one. Frank is putting together a bouquet of roses and daisies. He wants at least 1 rose and at least 2 more daisies than roses. Roses cost $4 each and daisies cost $2 each. Frank must spend $40 or less in this bouquet. If R represents the number of roses he buys and D represents the number of daisies, write out the system. Okay, so we're going to remember that R is roses, D is daisies when we do this. Okay, so let's go ahead and do this system. So just a quick reminder, a system of equations is 2 or more equations or inequalities. So the first thing that he says is he wants at least 1 rose and at least 2 more daisies than roses. So let's write an inequality for that. So it was at least 1 rose and at least 2 more daisies than roses. So that's my comparison. For every rose, he wants to have 2 more daisies. So what that is going to look like is, trying to read my answer key, at least 1 rose. R is greater than or equal to 1. Okay, at least 1 rose. Then at least 2 more daisies than roses. So my daisies, so writing that situation down, 2 more daisies than roses is, for every rose, we add on 2 more daisies. Okay? So again, reread that sentence and the inequality I wrote for it. At least 1 rose. R is greater than or equal to 1. At least 2 more daisies than rose. So again, for every daisy, for every rose, we're going to add on 2 more daisies. Okay, and then this last one is that money equation. So this should be fairly easy at this point. Is roses are $4 each, so that's my 4R. Daisies are $2 each. He needs to spend $40 or less. I get it, you're on a limited budget. All right, and here is my system. It happens to be 3, so remember systems are 2 or more. All right, let's go ahead and do B. B, we have math club members want to advertise their fundraiser each week in the school paper. They know that a front page ad is more effective than an ad inside the paper. They have a $30 advertising budget. It costs $2 for each front page ad and $1 for each inside page ad. The club wants to advertise at least 20 times. Write and graph a system of inequalities to model the number of advertisements the club can purchase to stay under budget. So again, 2 or more. So let's go ahead and label our variables since they don't label that for us. So we'll go ahead and label X and Y, and we can label X as your front page, and then Y is your inside page. And so let's go ahead and start for our money equation since they talk about that first. So we have a $30 advertising budget, so that means it has to be less than or equal to 30. $2 for the front page ad, so that is my 2X, and $1 for each inside page ad. So $1 for that, or 1Y, and so again, we have less than or equal to 30 because that's the budget. And then the last one, they want to advertise at least 20 times. Okay, so some amount of front page and some amount of inside is going to be greater than or equal to 20 because again, it's at least. So here is my system. Okay. Now, the very last thing we're going to do is we're going to just start number 4. So we'll get about halfway done and then finish it up next time I see you in class. So for number 4, we have Joanne likes her job as a babysitter, but it pays only $3 per hour. She's been offered a job as a tutor that pays $6 per hour. Because of school, her parents allow her to work a maximum of 15 hours per week. How many hours can Joanne tutor and babysit and still make $66 per week? And how much does she make? So we're going to come up with a sample solution here at the end. But let's go ahead. Like I said, we're going to get started. So we'll just start by labeling our variables, what Y equals, what X equals. So we're talking about her 2 different jobs. She's a babysitter and she's a tutor. So, and it's the number of hours that she works. So number of hours babysitting, and then number of hours as a tutor or tutoring. Now, the next thing we're going to do is just come up with the 2 equations or inequalities in this sense. Let's go ahead and start with that money inequality. So the babysitting is $3 per hour. So that's my 3X. And then tutoring is $6 per hour. So we're going to add on that 6X. And so what's the total money that she's looking for? And so here it says at least $66 per week. So she can make more, but at least 66. Now the next one is like the total number. So the total number is the total number of hours. So it's going to be some amount of babysitting plus some amount of tutoring, and she cannot go over 15 hours per week. That's her parents' maximum. So it has to be less than or equal to 15. Okay, and so here's our system of inequalities. So next time I see you, what we're going to do is we'll go ahead and graph and finish answering that. All right, thanks again, and I will see you next time in class. May the force be with you.